Welcome to the Pinecone. Previous episodes have stated how time series analysis is flawed and how market signals are both random and deterministic. So how do we smell what information is not on the graph? Wittgenstein can help explain. Wittgenstein, as told in an unconfirmed letter from the famous economist John Maynard Keynes, once stayed with Keynes at his home. There, after having Swiss cheese on rye, Wittgenstein requested to only eat that. Whenever a nice real meal was prepared for Keynes, Keynes would often say "hot ziggity," an expression he took up as a boy in Kentucky. Wittgenstein supposedly liked the phrase almost as much as he liked the toast. Keynes is said to have written that it was inconceivably droll to hear him exclaim "hot ziggity" whenever Keynes' wife put the bread and cheese before him. Wittgenstein has done other strange things, leading many others to make more stories about him. It is very difficult to find out what weird things Wittgenstein did while he was alive. Wittgenstein famously used rulers as an example in language games. He pointed out that the standard meter bar in Paris was the criterion against which all other rulers were determined to be 1 meter, but that there was no analytical way to demonstrate that the standard meter bar itself was 1 meter long. It could only be asserted as such as part of a language game. His deconstructions did not stop there. According to Wittgenstein's ruler, unless you have confidence in the ruler's reliability, if you use a ruler to measure a cup, then you may also be using a cup to measure the ruler. The less you trust the ruler's reliability, the more information you are getting about the ruler and less about what's in the cup. Wittgenstein's ruler dictates what information can be gained from a measurement or judgment, regardless of the ruler's reliability. It applies to tools like Monte Carlo analysis and the efficient market frontier, and can also be applied to people you hire or let manage your money. It is far more robust than personality metric pseudoscience. Financial professionals should not spend time wondering if their client is a Libra or a Pisces. The higher the tail and exponent, the better Wittgenstein's ruler works. The ruler states the following: if the device is not understood or trusted, the measurement will reveal more information about the device itself. If the device is trusted, it will reveal more information about the target. 3 things happen when you apply Wittgenstein's ruler. Measurement becomes bilateral. You're either 1 or 0. This is why the tail end exponent has to be high. Measurement is relative. This is the arbitrary axiom. And third, trust is important. Personal reliance on either the ruler or the cup is what enables progress. You must build insight bottom up from a starting point. This insight is known as intuition. And trust is not actually just an ideal, but rather a screening process we'll discuss later. Monte Carlo analysis is like a ruler. The market and our portfolio are the cup and what's inside. Standard deviation is a silly tool for investors. The standard deviation is not how something moves on average. Standard deviation also includes the squaring of a deviation. When you take the square of a deviation, it exaggerates the importance of larger observations. When we have a fat tail, this ignores our most valuable data. The tail end exponent of the Paretian distribution is 1.16. For this very common power law, you need a terrifying 1.86 times 10 to the 14th power more observations than a normal distribution to account for errors based off the mean deviation. Standard deviation is often referred to as STD. Mean deviation is far more robust than standard deviation. If the mean exists, then the mean deviation exists as well. Standard deviation is represented by sigma. Many goofballs like to throw around the term a 6 sigma event. This event falls outside 99.7% of expected scenarios. This is not necessarily a black swan. Sure, a 1,000-year flood out of infinite types of floods might happen roughly every 1,000 years, but don't tell fiduciary and frequentist statisticians, but it's not actually the same flood each time. Risk can also be multiplicative. A 100-year flood might cause more damage than a 1,000-year flood, simply due to the present state of architecture or health services. Suddenly we locally bifurcate into saying, applying this model is infinitely broken, because any variable can change everything. The downsides of a destroyed city far outweigh the benefits of starting your emerging town slightly closer to a river. Why? Because later when that asset is developed, that risk can spread to your other systems. This is known as a global frication. Stability analysis and global frications do not get along. So the next time you hear a financial professional mention standard deviation, tell them you already know all about their STDs. This has been The Appeal.